um, after today's session at 7:30, there will be a presentation by the Schulich UAV team. Just like one of the previous sessions where the Schulich solar power team presented, it's going to be kind of similar to that. Um, However, for this presentation, there won't be like ignite points for attendance, but the mentees are highly encouraged, and it's going to be really fun. And you guys are gonna actually get to learn a lot about their project and their research, what they have been doing so far. Um, so let's move on with today's session. Here we're going to look over another application of software engineering and two new important terms. One of them would be collisions, and the other one would be how we can be using images in our games. All right. So moving on. How good is actually a computer's nose? So numerous studies have shown that some dogs can detect diseases by smell, and it's like almost 99% accurate. So what a researchers team of from MIT are doing is that they're working on a way of automating the smell capabilities of the canine nose, and they are doing it with the help of a machine learning process. So what they are doing is that they came up with a system that can detect the chemical and the microbial contents of air samples with a greater sensitivity than a dog's nose. So that is really useful, and you guys can actually learn more about it in the link that's given at the speaker's note area. I think you guys have already access to the slides, and those are available in the website as well. So let's go for a quick review of functions, whatever we've learned so far. So functions are basically the block of code that we group together for easier use, which means like we make our code a lot more efficient rather than repeating a bunch of code again and again. So the body is that we define the function. We may have parameters or may not have parameters, and then we have to define the body, and then we go for return value. So one of the most common example that we always see is that our setup function where we do size 500 × 500 or maybe any other dimension as you wish. And then we call this my underscore function and putting in the parameters. So this function is actually referencing to the my underscore func over here. Some functions also take in parameters as input, such as one of the built-in functions that we use is circle, which is x, y, and z. We can also store the results of functions in variables. Okay, so we start off with the setup, and then suppose we have 2 underscore plus underscore 2. So this is the function that we are calling over here, and it is being stored in a variable x. Okay, and what we are actually printing out is that x plus 1. So the value that we are getting from this function and that value plus 1. So over here, what is 2 when we are defining the function 2 underscore plus underscore 2, what we are returning over here is 2 plus 2. And when we say return answer, this answer is being returned to 2 underscore plus underscore 2. And now the value of x over here is answer. So answer's value is 4. So it's 4 plus 1, and that equals to 5. So a new topic for today is collisions. Um, okay, so what are collisions? A collision is just a word for when we are moving an object, when a moving object makes a contact with another object. So as you can see by the example is that this block over here is getting bounced back from both the sides of the dimension over here that we have set up. So now we are going to learn how we can actually implement that with code. So let's actually look at the analogy of how they work. So to detect collisions, we will be using the bounding boxes. A bounding box represents the edges of the shape you're drawing. So over here, this shape is basically the bounding box. And as you can see, this red block is actually getting bounded from the side of this shape over here. So a bounding box, as we say, it's basically a rectangle, and these are basically the edges. And whenever the object hits these edges, they bounce back. And when the bounding box of two shapes overlap, we know there is a collision has occurred. So basically, as you can see, there is a space in between them, so there hasn't been any collision. So whenever these two stuck with each other, at that time we can see there is an overlap, and that's how the collision occurs. So this diagram actually represents like how the collision is actually occurring. So how we can actually define our bounding box? So it's basically going to be a rectangle, the rect function that we use. We can put in the parameters as we want to, setting up the dimension on how large we want it to be. So the same rectangle with a bounding box. Okay, so this is basically the rectangle, but this is a rectangle with a bounding box. So notice that the position and dimension of the bounding box and the rectangle are same. So yeah, as I've said before, the dimensions are going to be the same. The x value, y value, x coordinate, y coordinate, they're all going to be the same. The only addition that we're going to be using is this bounding underscore box function. So to create our own bounding boxes, we will be using a new function over here that's called bounding underscore box. And the parameters are very similar to the rectangle parameters that we've learned so far, which are x position, y position, the width, and the height. So we just replace rect with a bounding box. And yeah, we can actually store that in a bounds variable just to make it a lot more easier. Note that the parameters of the bounding underscore box are the same as the parameters of rect. As you can see, these are very similar. We store the return value of bounding underscore box in a variable. This variable will contain the position and dimension of the bounding box. Uh, so what bounds represent over here, as you can see, take this as an example. So we have a rectangle first, okay, where we gave the parameters x underscore plus, y underscore plus, w and h. And these values have been initialized with the values over here at the top, 0, 0, 50, and 30. Now what we're trying to do over here is that using that same exact dimensions, we are going to create a bounding box for that rectangle. And now what we're doing here is we're creating a bounding box with the same parameters, with the same values, and we're storing it bound. So now this rectangle over here, as you can see, becomes a bounding box. Okay. Next, another thing is how we can check if there are like two bounding boxes have collided or not. So this collided function is basically a Boolean function, so it's gonna either return true or it's gonna return false. Okay, so we create two different bounding boxes using bounding underscore box, and we pass these bounds as parameters in collided. So basically over here, as you can see that we've created one bound. So what we can do is we can create two bounding box. So it's going to be like two rectangles. Okay, so bounds one and bounds two. And then what we will be doing is we will be trying to see if they have collided or not. And for that purpose, we will be using the collided function, and then we pass in bounds one and bounds two. So the return value of collided will tell us if the two shapes are actually colliding. As I've said before, this is a Boolean function, and you can see that there is a space and they are not exactly touching each other. So there is no collision, and so this function will return false. Next, over here, as you can see, like as they are overlapping, so there is a collision that's happening. So this function will return true. We got the first quick question over here. So it's really easy and pretty much similar to the previous examples that I've shown over here. So which of the following statements are true for this collision? And the poll will be up on your screen. Make sure you guys put in your answers real quick. 30 more seconds. All right, I guess everyone has answered. Let me share the screen. Let me share the answers. Okay, so the correct answer is collided. Bonds and comma one comma bonds two will be true because from the diagram we see that one and two are overlapping each other. So if there is an overlap, the collided function will return as the true value. But if they are not overlapping, it will return as false. So that's the reason C is the correct answer. Um, let's learn how do we use the collided function. So create two bounding boxes, okay? And bounds one equals to bounding underscore box. We pass in these parameters, x1, y1, w1, h1, and for bounds two, we pass in the parameters x2, the y2, w2, and h2, okay? So now check if both boxes have collided or not. So for that, we will be using if conditional statement. So if collided, bounds one comma bounds two. So it's gonna say that if it is true, if that function is true, then we are gonna move on. If it's false, then we're gonna do something else. So if the boxes collide, define what should happen inside the body of the if statement. Suppose one of the example would be like either they're gonna change the direction, or the object is gonna be removed, or it's not gonna move, etc., etc. So let's actually look at a quick example over here, and we'll try to code a log. I'm gonna show you this one. Let me just go for split screen. So as you can see over here, first that we we have a bounding box, a huge bounding box over here. And I wouldn't say it's a bounding box. It's basically the size that we actually, the size of the, the size of the window. And then we have two bounding boxes. So over here, one of them is the red one and the other one is the blue one. So what they're doing is that they're moving from the opposite direction. They're colliding and they're disappearing once they actually hit the sides of the window. So as usual, let's start with record, ignite, and then first let's set up our window. I'm gonna give it size of 500 or 500. Okay. Next, what we're doing is, as you can see, the background over here is actually purple. So get the background purple. Okay. Next, let's actually draw the two rectangles. Okay. So one of the rectangle, as we can see, is the red one. So for that, as we've seen in the previous slides, let's give the parameters that are quite similar, W1 and W2. Okay, sorry, H1. Okay, and the other one would be, we also need another rectangle. For that, we're going to give X2, Y2, W2, and H2. Okay, so one of them has a fill style of red. And the other has blue. Okay, so we have to actually initialize x1, y1, w1, h1 before we are actually passing in the values over here. So let's actually initialize the values over here. So x1, I'm gonna give it minus 300. And what next? We'll go with y1. So why is it minus 300? Because you can see that it's actually getting disappeared on the left side of the window. It's not like bouncing back from the window. So And then for the width, I'm gonna go with, it's gonna be a 50. And the height, I'm gonna give it 100, okay? So for x2, we're gonna with 775, y2, it's gonna be 25, w2, 5, h2 would be 50. Okay, so also one other thing that we have to make sure that since we are using these parameters over here, okay, so we actually have to declare them to be global because we can't be because if not, then they will be considered as local. They will be considered as local variable, and we might run into a mistake. So let's actually declare them W1 and then H1 and another logo. X2, Y2, W2, and H2. Okay. So now let's actually try to use this piece of code that we have over here. So let's create this bounds. So I'm just gonna copy the code from here. All right, so now we've created two of the bounds, okay, using the values over here. The next thing that we will be doing is we are gonna check if they have collided or not. So for that, we'll be using the collided function and passing in bounds 1 and bounds 2. Okay. So if they are colliding, what is happening? We're seeing that they are going in a different way. They're not actually overlapping and going the exact same way. Okay. So for that, we need a speed variable. So the speed would be decremented by 1 every single time when they hit each other. So negative equals 2 minus 1, and speed 2 would be negative equals 2 minus 1. However, before we actually, we have to declare them over here as well. So this is going to be speed 2. I'm going to give it negative 4. And speed 1, I'm going to give it 3. Okay. Now, and also you can see we actually have to move the object as well. So for that reason, we have to use uh, one of the things that we've learned previously is that we have to increment x plus value, so it's going to be speed 1, and then x2, it's going to be speed 2 plus equals to. Yes, that's pretty much it. Let's see. Okay, probably range an error. And W Oh, okay. Sorry. My bad. No mistakes. Okay. Local vehicle speed 1 reference has been before assignment. So I think we probably did a mistake over here. Local variable and speed 1. Oh, okay. We have to also declare speed 1 and speed 2 to be global variable as well. Well, let's see. What is the problem? Oh, here. All right, yep, okay. You also have another problem. What's going on? Oh, no, give me speed. All right, it's working now. So sorry for that silly errors. So we have implemented the two things that we've learned so far is how we are creating the bounding box and also how we're creating the bounding box and also how we are using the collided function so that whenever we are actually merging them together, what is actually happening. And this gives us quite a bit of overview of what we have learned so far from the previous slides. And this is something that is going to be that your guys are going to be doing in your exercise after some time. So moving on, let's actually look at how it works over here. So how the collided works. So box one has left one L1 and right R1 edge, okay? So box two has L2 and R2. So whenever the edges overlap, so when L1 is less than R2, okay? When L1 is less than R2 and L2 is less than RL, the boxes have collided. So this figure does explain a lot about how the analogy behind the collided function works. I hope it's going to be a lot more clear if you guys go over it. So next, the same logic is needed for the y-axis as well using the top and the bottom edges. So when we are combining both x and y-axis for full collision checking. So over here you can see if T1 is less than B2 and T2 and B2 and T2 and less than B1. So T2 is not less than B1, so it's not colliding, okay? So it has got to be below T2 B1 in order for it to collide, right? So T1 is less than B2 and T1 is actually less than B2. And then we can see that T2 is less than B1 as well. So yes, it's correct. So that's the reason why we're seeing that the collision is awkward. So uh, an application, an example would be that whenever we are creating our games, we can see that these are some of the quite known examples. Suppose whenever this bird is flying, there might be a collision, and if there's a collision, the bird is dead, or probably this bar over here, it hits the bar that's at the bottom, and then it bounces back again. So yeah, these are some of the most known scenarios of collisions and bounding boxes in games. So this is the first exercise. So what you guys will be doing is creating a stroke rect function, okay, that follows your mouse along, okay? Create a target that moves from side to side. So whenever you'll be dragging, your the box will be moving as well. And over here you have to use collisions to check if the two rectangles are overlapping them, the mouse is pressed. Okay, so whenever you are actually trying to get that blue box over here with your rectangle, you see that a message is displayed and it says that you actually got it. Okay, so yeah, and you guys will be sent to breakout rooms. So just a quick reminder before that is since there was actually a problem with the server and many of you guys were not able to submit the exercises, so the the extension, there will be an extension for the due date for last week exercises, and it will be by it's gonna be like by next week. So it's gonna be like extended till next week. So you guys have like next week to actually submit previous sessions exercises. Okay. So yeah, and you guys will be sent out to breakout rooms right now to actually work on this, and I'm gonna give you guys around 20 minutes to work on this. So I have the usual things set up over here as from before. So the first thing that we actually need to do is create the blue box. So for that, it's we're gonna get underscore rect. Okay. Oh, 1 second. It's gonna be a fill rect with okay, before that we're gonna get the fill underscore style of blue. Okay, got it. So now, as you can see, we are trying to actually target the blue box, and we are moving the white square that we have, the transparent square, and trying to catch it. And at that time, whenever we are actually trying to get it, we display the message. So first, let's actually construct with the blue box and the white square. So or we'll come back to this later on. So for the white empty square part, let's go with the stroke underscore style. We're gonna give it a red. Okay. Next, it's gonna be the stroke underscore red. I'm gonna give it mouse underscore x. That would be negative like 15. Mouse underscore y. Negative 15. 30. 30. Okay. So after that, let's actually complete this as well. So we will be using the four parameters over here. One is target x, target underscore y, because we're targeting its coordinates. The height and width would be like a square. So let's actually initially declare over here target underscore x would be 200 and target underscore y 200. Okay. And we also need to give a speed because it will be moving, right? So let's give it a speed. We initialize it by 5, and after that, now let's see if target underscore x plus 20 is the initial and then width, or is the target equals to 0. Then what we will be doing is we will be indicating the speed by 1. However, on the other hand, the target underscore x would be incremented with its speed. Okay, so next, let's try to actually do it for the stroke. I think the stroke is quite done. Okay. Okay. Moving on. Maybe I can show the server today. All right, so we're back. Let's finish it up. Okay, so now we have to create a bond for the target. And for that, we will be using target underscore bond and next, as usual from previous that we've learned, let's use the bonding underscore function. We will be passing in the parameters target underscore x, target underscore y, 20, and 20. Okay, now, I think, oh, uniform and safe. Okay, let's go actually, we start the parameter. Well, we call e. E. And then last, now we also have to create a bond for this over here as well. And let's go bonds, bounding, and let's go box. Okay, now for the collision, part if added, and we're passing in two parameters, target, and there's the bounds, player, and there's the bounds. And then since we will be giving out a comment with our expressed, so this style would be black. Next, and it will be size is 30. Target underscore x, which reference so color wrapping thinner. Oh yeah, correct. This should be global. Uh, uh, it's working. Let's try it on. Yeah. So I think yeah, it's working right now. So as you can see, whenever I'm actually trying to hover over it, and then whenever it comes into the rectangle instead of the rectangle, and I try to click with my left click with the left mouse button, and it says like you got it. So yeah, this was actually pretty much like an overview and a complete exercise of the entire collided function and also the bounding box function. So the next thing that we have is how we can use images in our program. So adding images to our game. So we can also add images to our game using the image function. And the images can be used for backgrounds and also for characters and for any other game element as we wish to. So the function that we use is image, the image name or the file name of the image, xywh, which is pretty much similar to the other function, predefined functions that we learn. X is the x coordinate of the top left corner, y is the y coordinate, w and h are the width and height. So don't change the width or height of the images over time because it's gonna actually decrease the quality of the image, and there might be a problem when setting the background as well. So uploading our images, so what you need to do is basically after you download the files, image files, you can, if you're using Windows, you can just like drag those two images in your Jupyter notebook. As you can see, I've done it over here. Yeah, I've downloaded these images and dragged them over there. So yeah, that's how you can do it. And then now type in the following. You can type in your image, give the specific coordinates that you want to, and yeah. So this is an example of the images. I tried running it for some time. Let's see if it works right now, because today our server has been down for some issues. And yeah, it's finally working now. So as you can see, what we did over here is that we defined a window 500 by 500. And yeah, this thing is not necessary for the time being. And then we gave the background image to be, a space background image. Okay, we set the following coordinates, and then we set the spaceship image to be our cursor. So whenever we're actually moving it, it's moving along with our cursor as well. Okay, and we also give its coordinates over here. So it's kind of like moving it into mouse underscore x and mouse underscore y as well, both the directions. Next, we have projects. The projects that you guys have, these are all optional. You guys will be creating your own project, working on with your mentor as well. So this is highly encouraged, but it's optional again. And you guys can earn up to 250 Ignite points for one specific projects, and they will be marked on five categories: readability, efficiency, novelty, functionality, and complexity. Okay, so 50 points are categorized for each of them. Okay, so the project rubric and each category description can be found in the Ignite Points spreadsheet, and you can submit as many projects you can like. And the deadline is December 8th, 12 noon. Okay, 12 p.m. So you guys will be making projects by using all the slides or so far what you guys have learned in the past 7 weeks. And yeah, and you can even create your games, anything that you want to. And in order to submit your projects, it is the same process that you do use for your weekly and social media challenges. For the Blockbusters, there is a form, and for the Platonic Lava, there is also another form. You'll have access to these forms whenever you guys get the slides. I think it's already available in our website, or probably someone is shared in the Zoom chat as well. And the additional information is, if you want to present a project during the GALA event, make sure to have your project ready for presentation by the day of the GALA event. So as I've discussed, as I've said previously at the beginning of the session, probably in session 0 or session 1, that our main event would be the GALA event, and there will be uh, yeah, so there will be like industry speakers from different various industries, and you'll be getting the chance to showcase your projects in the main room to them. This is optional, however, it is very highly encouraged. And the registration link will be sent to your emails very soon. So for next week, what we have is that we'll be playing a game of Kahoot on everything we have learned so far, and there will be 9 points awarded for to the top scores of each group. And the rest of the session will be for you to work on your game, to work on the exercises or the projects that you guys are willing to work on. So these are the projects, these are the exercises for week 7. The bug busters over here, and also there are Pythonic lavas. So, and these are for just for fun, as you can see. And yeah, this might be one of those projects that you guys can actually come up with. As you can see in the rubber ball challenge, it shows like the collide it's pretty much similar to what we have learned today. The bounding box and collided functions are also being used. Also over here, it's a flappy blob. So yeah, now you guys will be sent out to the breakout rooms, and you can start working on these exercises or probably the previous exercises which you guys were not able to finish up. And we'll be seeing you guys at 7:29 here. Team, so just a quick reminder that there is going to be another poll before Alex takes over. So it's going to be popping into your screen right now. All right, I assume everyone has put their votes on the poll, and I'm just gonna hand it over to Demeter. Yeah, Demeter, you can take over from now.
Thank you. Yeah, so that wraps up the session that we had for you guys today. Now we're going to pass it over to Alex, who's a representative from the Schulich UAV team. And yeah, he'll just share his screen and do a presentation on their club and how software plays a role in their team. And yeah, that's everything. So I'll pass it over to Alex now. I mean, encourage everyone to stay.
Hi. I'm Alex. I'm the software lead for Schulich Unmanned Aerial Vehicles, or SUAV for short. We're a team that focuses on designing and manufacturing different UAVs and aircraft for competing competitions. So in the background here, you can kind of see one of our previous planes that we've built and flown. This one's about 5-meter wingspan, so it's a pretty big one. And it was capable of autonomous flight and taking photos, taking aerial photos at long range distance. So we are underneath the UFC and Schulich engineering faculty. Just a couple of photos here of previous members of our team. The top one is that same plane as was in the previous slide. And on the bottom is another plane that we designed in the past. The top one being for a capstone project. So that's the final project in the last engineering year that students partake in. And the bottom one is for a competition that was in the United States that was created, that plane was created for to compete in. So for projects that we're currently working on, I have been working on very recently, SAE Aero Connect is a design competition where we spec out and designed lots of research into to create these concept aircraft. So this was for a theme park, which was requiring aerial transport for customers. So we designed this plane, all this aircraft, as you can see here. And so we did lots of research and speccing out potential solutions for how we would solve different aspects of the problem. Another competition that we competed in before was the SAE Aero Design. So that's going to be a competition where we had to fly this plane on the left over and drop payloads at specified location, in this case, which is water bottles and Nerf footballs. So we had to have specified location to drop them at, as well as 2 gliders that was released from the main plane to land at specified locations. And you can kind of see on the right, somewhat manufactured plane. Didn't get to finish it actually because of the pandemic. And then the bottom is the one of the gliders that was prototyped out. So in terms of software, actually what we do, so all of our planes and our craft run on ArduPilot, which is an open source autopilot for aircraft. We put these onto our flight controllers and we load it onto the aircraft and we're able to communicate with it from our ground station. So in the top right, you'll see kind of a dashboard that we use to communicate with the plane and specify what we want it to do. On the bottom right, it's kind of an example of a flight plan. And one of the greatest parts about open source software is because we can modify it all we want. So what this competition included was, for this particular competition on the left, they had to open up a bay door on the bottom of the plane. So they had to do custom modifications to the autopilot software to accommodate this. So when you're in X location, drop the thing. And this was, this is a regular thing through some of the competitions that we do. They need specified drops. So we have to build in calculations. Okay, this is the plane's current location. This is our current wind speed. This is our current, this is the target location. Do a bunch of calculations on the fly to determine when to actually drop payloads and when to release different objects. So that's on the autopilot side of things. More recently this year, we've been moving more into autonomous object detection. So that includes some machine learning models and some computer vision libraries that we use in C++ and Python that we're then able to do autonomous object detection. So we're able to tell what the object is, where it is, like an exact GPS location of it all, how it's rotated and all that. So this is a kind of an ongoing project, but it's pretty cool, as we're able to determine a lot of information just from flying over. And another part that we've been working on is creating orthographic photos. So using these same images that we take from the plane, we're able to stitch together these big orthographic maps, effectively similar to a bird's eye view or a satellite view. If it was taken, we're able to get high quality, high resolution stitched images that we have to submit as part of this one of the competitions that we're competing in. But yeah, that's kind of a brief overview of who we are, what we do, and kind of how it ties in with software and what we do, kind of stemming from like what we've been working on and how we're able to take existing software and tie it in with what we need to achieve. And I believe that we're able to have a short Q&A session, if I'm correct. Yeah, so if there's any questions, you can, I guess, unmute or pop it in the chat or whatever. We do actually, we're not recruiting right now, incidentally, but we do recruit at the beginning of the school year. So if you are attending U of C in the fall, do consider us. And we actually do take some high school students, depending on the situation. So it's not specifically university, but it's case by case, we'll see, based on kind of who applies. But yeah, we try to get a good mix. Where does competition take place? So the Aero Connect competition, which we are competing in again this year, that's held down in LA. So we have to fly. We have a small team that flies down to Los Angeles to compete. And that one's entirely designed, so we don't actually have to bring the plane with us. We show it. We have like a booth that we have to show off. And then the competition this year, where we're actually flying a plane, we have fly down to Maryland in the US as well. And we have to bring our plane along and assemble it all there and fly a competition there. What programming skills are you looking for with new members? The biggest thing, honestly, I can say is somewhat to an extent familiarity with what we're working on definitely helps. The ability to pick up object oriented is definitely an asset, but I'd say the most useful part is if you're able to pick up a lot of it on your own, learn new skills fast. And that somewhat comes with practice as well, and something that just comes with doing your own learning is being able to go out if you're given something, because what we do is kind of separated. It's quite far away from what you'll find in the classroom. Especially with in general, I'd say the classroom has useful you'll get important basics there, but a lot of the stuff you'll learn on your own, and that's going to really give you useful stuff that you won't really get from the professors. So being able to pick new things up, being able to just learn things fast and kind of on the go and figure out how they work is, in my opinion, the most important. Okay, well, I don't want to waste too much more of your guys' time here. But yeah, thanks for having me in the talk about kind of who we are. And yeah, have a great evening, everyone.
Awesome. Thank you, Alex. That was really good to see. In that case, I think that wraps up our session for today. Yeah, we'll see everyone again next week. Thank you again, Alex, for coming, and have a good night.